two very important things to remember when dealing with proportionality in graphs is that proportional relationships are linear. Okay, let's talk about that word linear just for a second. Do you see the word line in it? Oops. Try that again. Linear line. Okay, now you can see the word ear too there, but proportional relationships, the graph of those must be linear, must be a straight line, and they have to pass through the origin. Now, if they don't, there's absolutely nothing wrong with that, except it's just not proportional. Origin, remember, is the point 0, 0. So let's graph these tables and see what we come up with. Remember, these are ordered pairs, and you don't have to write them as ordered pairs unless it helps you, but make sure we're going left and right first, then up and down. So we have 1, 1, 2, 3, and then we have 3, 5, and 4, 7, and 5, 9 is going to be off the graph. But you can pass a line through these, being as exact as I can. What do we notice? Let's see if I did this right. I think I got too excited. Oops. All right. If I'm looking at these closely, this actually doesn't go through because I'm looking at it as like we go down 2 to the left 1. If we go down 2 to the left 1, it's going to hit right here. So that really doesn't hit the origin. Even though it's super close, it doesn't hit the origin. So we'd say example 1 is not proportional. Why? Because it says explain. Very simply, because, oh, that's an E there. It doesn't go through the origin. And that's one of the guidelines for being proportional. To go through the origin, 0, 0, and be a straight line. So let's try another example. Try to see if I can get this one right. So we have -3, -6. We have -1, -2. We have 1, 2. And 3, 6. And 5. Oh, it's going to be off the board. All right. I draw a line through this one. Okay. And try not to hit other buttons. And try to be a little more exact, not just through my marker, but through the grid lines. I think we're pretty close there. The perfectionist in me wants to get it exact, but we'd say that this one is proportional. Example 2 is proportional. Ooh. Because, sorry guys, I am struggling with my writing tonight. Because it's linear. Remember, that means it's a straight line. And goes through the origin. So to be proportional, both these things must be true. Really sorry about the sloppiness, guys. Example 2 is proportional because it's linear and goes to the origin. Okay, last example for these. I'm going to plot the point 2, 1. Now remember, 2 is the x values. That's this one right here. This is the y. So I go 2, 1. 4, 2. 6, 3. 8, 4. And then 10, 5. So if we draw a line through that, sorry, you guys have to watch me try to draw these lines. There we go. I would say it looks like a straight line and goes to the origin. So we're going to say it's proportional. Proportional because it's linear. And remember, linear is a straight line. And goes through the origin. Okay, so now we know proportionality in graphs. It has to be straight line, yes, but not just a straight line. It has to go through the origin. So use your understanding of proportional graphs and tables to answer the questions below. A number of feet in a yard can be represented by a graph. Which of the following graph best represents y, the number of feet in x yards? Well, if there's y feet in x yards, I know there's in 1 yard, there's 3 feet. In 2 yards, there's 6 feet. And, you can keep going. So to me, these appear to be the ordered pairs x, y first. X, y is 1, 3, and 2, 6. So look at these. 1, 3 is right here. 1, 3 is right here. 1, 3, maybe. And 1, oh, that's 6. 3's here. Okay, so I know for sure it's not D, and I know for sure it's not A. Let me try the next one. Let's try 2, 6. 2, 12. Oh, we already said it wasn't that one. Okay, 2, 6. Oh, looks like it works on this one. And 2, no, 2, 6 isn't gonna, it's gonna be off there. So it looks like we have B for an answer. Which of the situations best describes the graph at right? Okay, I want you on any of these type of problems to focus on one, on the x-axis. That is going to be your unit rate. So your focus needs to be here because it means that one object, so in this case smoothie, it costs $12. Well, that can't be A. A runner can run 6 miles in an hour. Well, it's 1 hour, but that would be 12 miles. There are 12 cookies in a dozen. Well, in one dozen, 12 cookies. That's a possibility. Or you could go 1 mile in 6 hours. That doesn't work. So by process of elimination, this graph best represents 12 cookies in 1 dozen. So 2 takeaways from this lesson. Proportional relationships are linear, which means a straight line, and they have to pass through the origin.